Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, halogens. What are halogens? What kind of elements are they? So, halogens are elements that are in group 7 and they are non-metals and they are all diatomic molecules as elements. So let's think about that for a second. They're in group 7, which means they have 7 electrons in their outer shell, which means in order to have a full outer shell, they would need to gain an electron. So if we think about chlorine, for example, and we have that diatomic molecule Cl2, two of those chlorine atoms join together with one single covalent bond so that they can share this pair of electrons and they can effectively both have that full outer shell. The hydrogen compounds are acidic, so let's take, for example, hydrogen chloride. So hydrogen, a positive ion, and chloride, a negative ion, when they join together, and then if we put them into water, you get hydrochloric acid, okay, as those hydrogen ions dissociate. And it's the same for other halogens, hydrogen compounds, they're acidic as well. How do their properties vary going down the group? So they become less and less reactive the further down the group you go. Remember, that's the opposite to my alkali metals. And the reason for that is the group that they're in. So again, thinking about their electron structure, they want to gain an electron to have a full outer shell. The easiest way to gain an electron is for one of the shells that's quite close to the nucleus, because the nucleus has a positive charge. So in the smaller atoms where that outer shell is quite close to the nucleus, that's easier to gain an electron because it can attract an electron in. They get darker in colour as we go down the group, and their boiling points / their melting points also increase as we go down the group. And that is to do with, again, the molecules experience these stronger intermolecular forces as they get larger, basically. Okay, redox. What is a redox reaction? Well, we're going to talk about them a little bit on this slide, but it becomes a little bit more obvious when we do some actual examples on the next few slides. So redox is simultaneously reduction, read, and oxidation, ox, happening together. And that makes sense. Remember, reduction is loss of electrons and oxidation is gain of electrons. So a redox reaction is when one of the species in your reaction loses electrons and the other one gains those electrons. So these electrons are being transferred. What is a reducing agent and what is an oxidizing agent? So the thing that reduces something, i.e. gives the electrons to something else, is your reducing agent, okay? And your oxidizing agent is the thing that does the oxidizing, i.e. steals electrons from something else. And the problem with these two things is there's a bit of a misconception about the reducing agent is not the thing that is being reduced. Okay, so you have to get that the right way around. So here written, these will always be oxidized themselves, whereas the oxidizing agent is not the thing that is being oxidized, it is actually the thing that is being reduced. If we think through just one of those for a second, if something is the reducing agent and therefore is giving electrons to something else, it itself is losing electrons. So if I think about what is happening to the reducing agent, it's losing electrons, oil out of my oil rig, oxidation is lost, so it is being oxidized by being the reducing agent. So that's really quite confusing. So make sure that you're happy and you've got that straight in your head. So let's do some examples, redox and displacement, so we can talk about reducing agents, oxidizing agents, what's what and what's going on here. So how do we work out what is reduced and what's oxidized in terms of electrons? So we need to look at the charges of the particles basically and see what's happened to them. Let's do it with an example. So let's follow this reaction, what is reduced and what is oxidized here. So first things first, my magnesium there is just, it's pure element, so it has no charge as part of my reactants on the left. And then my products on the right, that calcium there is a pure element and has no charge. This though here, we've got our ionic compound, okay? And that is my calcium selenide, and it's made up of calcium ions and selenide ions. So your calcium ions here, they are in group 2, and therefore they have a charge of +2, and they lose those 2 outer electrons. And your selenide is in group 6, and therefore has this -2 charge as it gains those 2 electrons to fill its outer shell. On the right-hand side, we have magnesium selenide. Again, magnesium is in group 2, so same story, we'll lose those 2 electrons to get the full outer shell, and your selenide is in group 6, gains 2 electrons to get that full outer shell. So you've got +2 magnesium, -2 for your selenide here. So first, the magnesium. It starts as a neutral atom, as its pure element, no charge. And then on the right-hand side of my equation as the product becomes these +2 ions here. So you've gone from magnesium to magnesium +2. And therefore, what must have happened is your magnesium here must have lost those 2 electrons. So on the right-hand side, you now have this positive magnesium ions and 2 free electrons here. Since it actually has lost those electrons, oil rig, it must be oxidized, okay? Oxidation is loss, and that makes it the reducing agent, okay? Whereas for the calcium, you start with these +2 ions and it becomes just the pure element calcium. So what's happened there is you must have gained 2 electrons. So your ions gain the electrons to become calcium. And since you've gained the electrons, reduction is gain, your calcium has been reduced, which makes it the oxidizing agent. Okay, let's do another example here. So write a balanced symbol equation for a reaction between bromine and sodium iodide, which has been oxidized and which has been reduced, which is the oxidizing agent. So bromine is your halogen, which is more reactive than iodine. So what you can say is that bromine will be able to displace iodine. So for my symbol equation, my balanced symbol equation here, we have bromine, which I have to write Br2 because it's a diatomic molecule, it's my halogen, plus this sodium iodide there, and that's my ionic compound. And therefore, in order to have come up with that formula, I had to check sodium has a +1 charge because it's in group 1, and my iodine has this -1 charge iodide because it is a halogen in group 7. And so +1, -1, those are all balanced, so just NaI. And then what do I get out the other side? I get sodium bromide here. And again, sodium +1 and bromine -1 charge here, so that's fine. Plus my iodine, which again, diatomic, so I write it as I2. Okay, now this here isn't quite balanced yet, so I need to first balance this symbol equation. Okay, let's just write that equation out again on this fresh page. Good. So at the minute, I'm looking at this and I am seeing that it's not balanced, so I need to balance it. And what I've done is noticed on my right-hand side, with my iodine there, I have 2 of them, whereas on my left-hand side, I only have 1 in that sodium iodide. So I have added a 2 in front of that sodium iodide, and then on my left-hand side, now I have 2 sodium, and on my right-hand side, I only had 1 sodium, so I added that 2 in front of that sodium bromide as well. And that has also fixed the problem of having my 2 bromine on the left-hand side and only 1 in that sodium bromide on the right-hand side. So this is balanced. I've got my state symbols. Bromine's a liquid at room temperature. I've got my aqueous solution of sodium iodide, aqueous sodium bromide, and my iodine as well. So if I think about what happens to my bromine first, well, if I look at my left-hand side, it's neutral, okay? It's just a diatomic molecule, an element. And then on my right-hand side, it has joined part of this ionic compound, and it has these negative bromide ions, and they have a charge of -1. And on my right-hand side, I have 2 of those negative bromide ions. So that must mean that my bromine gained 2 electrons, so that 2 of these bromide ions is what I've got on my right-hand side. Now, if I think about my iodine, on my left-hand side, I've got 2 of these negative iodide ions. And then on my right-hand side, I've just got my iodine, which is neutral. So it must have gained 2 electrons to become this neutral iodine on my right-hand side. So each bromine gains an electron. Oil rig, oxidation is loss, reduction is gain. So my bromine must have been reduced, which makes it the oxidizing agent. So remember that. They shouldn't both say reduced and the reducing agent there. If the thing is being reduced, then it is the oxidizing agent. Each iodine loses electrons, so it is oil. Oxidation is loss, so it is oxidized, which makes it the reducing agent. That's sodium iodide for my reducing agent.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, tips and tricks for this section. So you can think of halogens as the alkalis, but similar but opposite. So halogens need to gain 1 electron to have their full outer shell, whereas your alkali metals need to lose 1 electron to have their full outer shell. And the way we talk about their reactivity, therefore, there's a lot of similarities. So remember, it was about how easy or hard it is to gain or lose that electron. And the bigger your atoms get, the easier it would be to lose it, but the harder it would be to gain it, which is why those reactivity series kind of go the opposite way round for alkali metals to halogens. Okay, if you don't have a strong understanding of ionic formula, then you're bound to struggle with these redox reactions. So again, it always comes back to these basics of being able to work out what ions different compounds are made of, given the group, for example, that they're in, and being able to work out the charges.